about a raised to n, b raised to n, and c raised to n, where the number of a, b, and c's are equal. So let's start. So how the code actually works is that when it is you start with QA, or like in state QA. When it finds an A, it will transition to state QB. But when it finds an A, it will mark A as X and then transition to state QB. Once it finds like that. Once it finds a QB, when in QB, once it finds a B, it will mark B as Y and then transition to state QC, wherein it will find a C. There, and once it finds a C in state QB, in state QC, I mean, sorry, it will go to state QX and marks C, the previous C, as Z, and then finds the initial X, as you see here. Let's speed it up a bit. It basically does the same thing over and over up until there are no more inputs. The process of like going back to X, going to A, finding B again, marking B as Y, going to C, finding C, marking C as Z. And then once we're actually here at, oops. So basically what happens is that when you're like in QA and you find a state called Y, you basically go to like QE to go to like the last output, QE after. So as I was saying, when it goes to look for like QX and it finds QX, you go back to QA. And in QA, once it sees a Y, it'll transition to state QE, and therefore ignores everything else, assuming that there is no other like variables such as B or C in between, and then goes towards the empty tape and then accepts.
So this is the Turing machine for our number 2. Yeah, it's just supposed to be a modification of the example number 4 from the slides, but let's try and explain it anyway. So the starting state is Q0 and the accepting state is QF. Actually, we should explain what it's supposed to do. So what it's supposed to do is to get a substring like AB with C in the middle, and then have the next substring followed by following C to be the homomorphism version. Yeah, the homomorphism version of the first string before C. So here's how the Turing machine's code is laid out. Of course, we start with the initial state, which is Q0. If it finds an A, it will transition to QCA, and then it will change A into X and move right. Same thing if it encounters a B, except it will move into state QCB, still change it into X, then move right. This part in the code doesn't come in until later on, because this will be when the code is already completely masked into X's and Y's. So let's save that for later. So here, QCA, if it sees an A, it will just move to the right. It will just leave the A alone. Same thing with the B. Since QCA is the state wherein it's looking for a B after C to match A. So let's leave QCB for now. So once QCA finds a C, it'll transition to QB. If you paid attention to the slides before, this is supposed to be the part where it turns to QA, but this is the first modification, where instead of going to QA, it goes to QB. So let's look for QB. Here, QB, this is the state where it's looking for a B to match the A from the first substring. So now it's found a B. It'll transition to QX, paint the B as Y, change it to Y, and then start going left. So if it sees a Y, it'll just keep going right. So the QB will keep moving. Well, and then paints it as Y. So yeah, we go to QX. So here, if QX finds an A, it'll keep going left. If it finds a B, it'll still keep going left. QX, if it finds a C, it'll keep going left. But if it finds an X, it'll transition back to the starting state, Q0, and go back to going right. So here, Q0 will go back, and it will see if it sees an A or a B instead. And then the cycle continues until the whole thing is X and Y. That's where this part comes in, the Q0C and QEC. Huh? A-play na lang. Oh, yeah. And then it will just like accept. So let's just look at it now. So here it's found A, so of course it goes to QCA. It goes through the first substring, and now it's seen C, so it goes to QB. Finds the B, so it goes from QB to QX. And now the QX has found X, so it goes back to the starting state. It's found B, so it's QCB. Now it's found C, and now it's going to look for an A to match the B with. Of course, it's found it. Now it's in QX. Now it's going to look for an X, and it'll keep on going to the right. And the process will keep going. Yeah. There, the A has been matched with the B. Now it's been turned to a Y. Now it's found the X again, and then the B. Now the C. Now to look for the A. Yeah, it's getting there. it'll find the X, and then there, and now it's in QE. If QE doesn't find anything, and then it's just the no input, it'll go into the accepting state.
Okay. So for the third problem, it's an even palindrome. So as the name suggests, the input should be even. For example, we have this, so let's load it. So the first state is Q0 here, which is also where the first symbol is. Then it will mark the first state as X. Then it will then find its pair symbol, so it will transition to QA. There. To QA and find the rightmost space. Then it will transition to QAA and mark the pair of the first symbol as Y. So next, it will then find X. After you found X already, it will transition to the next symbol beside it and mark it as an X2. Then it will repeat the same process as what she did a while ago until all the symbols are paired already. So this is an overview of the code for the even palindrome. So this here, where you mark A, the first A you see is an X, then you mark its pair as a Y, which is here. And here it's also, well, this is for the B, where, yes, you also do the same as an A. You mark the first symbol you see as an X, and its pair symbol as a Y, which is somewhere here. I hate that.
When the input is A, basically the output would be B, and when the input is B, the output would be A. And when the input is AB, the output the output will be BABA, and when the input is BBAA, the output would be AABB. So in this Turing machine, the initial state is QO and the accepting state is QL. When the Turing machine is in the starting state, and when it sees when the blah 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 machine is at the starting state and it sees a B, it would transition. Puta ka. It would transition to state QB, and when the first letter of the input is A, it would transition to state QA, as is shown here. Ay, puta ka. As it is shown here, and then moves to the right of the input, and moves to process the character on the right side of the first letter. While in the state QA, when it okay, from QO, the Turing machine would transition to state QA or QB depending on the first input, and it will replace the first input with a big letter X. When it's in state QA, when the first input is A, it would transition to state QA, and when the first input is B, it would transition to state QB. When in state QA and QB, these are the states that would replace these are the states that would replace the other inputs from small letters to big letters. For example, a small letter B would be replaced with big letter B, and a small letter A would be replaced with the big letter A. And when in state QA and in state QB, if it doesn't, and if it encounters a space or the end of the string, if it encounters the end of the string, it will transition to state QEA. When it's in state from state QA, it would transition to from state QA it would transition to state QEA, and from state QB it would transition to state QEA. If while in state QA while in state QEA, the Turing machine and QEB while in state QEA and state QEB, the Turing machine will will get the inputs will move left until will move to the left, replacing the big letter A's with small letter B's. Thus, this is where the reversing occurs, and the big letter B's with the small letter A's. And when it encounters the X at the start, it would and when it encounters the X on the start of the string, it would putang ina. And when it encounters the X at the start of the string, it would and if it encounters the X at the start of the string, depending on what the start of your string is, whether it's if your string started with QEA, the QEA would transition to state from state QEA, it would transition to state QE, and it will replace the X with B. But if it's started with a B, your current state would be state QEB. Your current state would be state QEB, and state QE would be and state QE would be putang ina. And state QE would be fuck you. And state shit. And state QE would be and state QEB would transition to state QE, while and then replace the big letter X with the small letter A, so thus reversing the first letter of the string. And while it is in QE, while it is in QE, it would move to the it will one by one move to the right, disregarding the string until it sees a blank space where Q until it sees a blank space. And when it encounters a blank space, it will from state QE, the Turing machine would transition to state QL, thus accepting the string, and the string would be reversed. Da 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 da.